So the purpose of this video is to discuss how we actually do graphs of the equations that we've been working with so far, particularly these quadratic equations, these polynomials. And in particular, we want to graph polynomials that are of this general form that we've been working with: ax squared plus bx plus c is equal to 0. And what you see is you'll see them written in a slightly different format. You'll see them written, instead of being equal to 0, you'll see something that looks like maybe y is equal to x squared minus an 8x plus 14. And it looks a little bit different, but it's the same thing. We still have an a associated with this x squared. We still have an x with a 8 instead of a b, and we still have a c equal to 14. So let's write down what those all are. We have our a variable is the whatever number is in front of the x squared, which in this case is a 1. We have our b, which is whatever is in front of the x. In this case, that would be a negative 8. And we have a c, whatever is the number that's just sitting out there, that's just going to be equal to 14. What we want to do, we want to try to graph this. But to graph it, we need to know some information about it. First, we need to know in general what it's going to look like. So all these quadratic equations, all these formulas, all these equations that are of this type are going to have the same general shape. If I draw an x-axis and a y-axis, all of these kinds of formulas, these equations, are going to look like something called a parabola. So they're all going to look like a little U shape. And what we need to do, we need to use these three variables, this a, b, and c, to figure out what this shape is going to look like. We could have this this kind of U shape that I have. We could have downward shaping U. We could have it shifted. It could be sitting farther over on the x-axis. It could be sitting further over on the x-axis and pointing down. It could look a lot of different ways. And we can use these variables, this a, b, and c, to figure out exactly what it'll look like. And the approach to do that is to first find something called the axis of symmetry. And the general equation for finding the axis of symmetry for a polynomial, for one of these quadratic equations, is going to be x is equal to negative b divided by 2 times a. And what the axis of symmetry is going to tell us is what point we're symmetric around. So what does that mean? Let's draw just a general graph, a general shape. We know this equation is going to look like this kind of U shape. And if we can imagine taking a line and cutting it in half, I'm going to draw a line that cuts this in half. And I can see, if I look closely, and if I could draw a little bit better, that the right side of this looks exactly the same as the left side. So this little line that cuts it in half so that you get the same kind of picture, same kind of shape on the left and right side, this is called the axis of symmetry. You can also think about it as if this were a sheet of paper and you folded it in half, then the two sides of this line would match up with each other. So to find the axis of symmetry for any polynomial quadratic equation, we take this. X is equal to negative b divided by 2a. And for this case, we already found what a, b, and c were. You can rewind a little bit to see, or I'll just remind you that b was equal to negative 8, and a was equal to 1. So the axis of symmetry for this particular equation that I'm talking about is going to be x equal to negative b, where b is equal to negative 8, all divided by 2 times a, where a is equal to 1. So the axis of symmetry here, if I simplify this, negative times negative 8 gives me positive 8 divided by 2. So my axis of symmetry says x is equal to 4. And now this is where I can start to draw pictures. I know that I'm going to have an axis of symmetry at the point along the line x equal to 4. So I need to keep that in mind. This is my axis of symmetry. And we'll see how to use that to draw an actual picture in just a couple minutes. So once you have your axis of symmetry, you can take that axis of symmetry, x equal to 4, and you can plug that into your y equation. So you're going to plug in y equation, which was equal to x squared minus 8x plus 14. And you're going to plug in your point where the axis of symmetry is. So I'm going to plug in 4 for x and find what y is. So y is equal to 4 squared. I'm just plugging in 4 for that x. Minus 8 times 4, where again I plug in 4 for x, plus 14. So I'm going to solve this out, multiply all these numbers out, plugging and chugging. 4 times 4 squared is 16, minus 8 times 4 is 32, plus 14. I can add all these numbers up, and when you do, you will find that y is equal to -2. So what we've just found here is something called the vertex, and there's a couple places where you have to calculate vertices on your worksheet. So the approach to do that is to find this axis of symmetry. You can rewind and see how to do that. Plug in this axis of symmetry and solve for y. And this point, x is equal to 4 and y is equal to -2, has a specific name. It's called the vertex. And this tells you the central point around which you're going to draw your whole graph. Vertex is 4 and -2. And what you want to do, you want to make a table that centers around this vertex. So how do we do that? Well, I'm really just making a table to find out what my y values are for any given value of x. I'm going to start with the point x equal to 4, and I know that y is going to be equal to -2. So this table that I'm making is really a table of x values and y values. And I'm going to go symmetrically along either side. So since this 4 is the middle point, I'm going to increase by 1 to say x equal to 5 and x equal to 6. And then I'm going to decrease in the opposite direction to find x equals 3 and x equals 2. So I'm going to find 5 different points that will be on this graph. And to do that, all I do is plug in the x value for my y. Remember, y is equal to x squared minus 8x plus 14. I plug in this 6 for this x. So I get that y is equal to 6 squared, plugging in for my x, minus 8 times 6 plus 14. I plug all these numbers in, I do out the actual algebra, and I find that y is equal to 2 when x is equal to 6. I follow the same procedure and find y is equal to -1 when x is equal to 5. When x is equal to 4, I already know that y is equal to 2. When x is equal to 3, y is equal to -1. And when x is equal to 2, y is equal to +2. And all I did was plug in these x values into this equation to find what the y values are. So just plugging and chugging. And now I have a table of a bunch of different values. I can take this and I can make my actual graph now. So if I draw coordinate axes, I have an x-axis and I have a y-axis. And I'm going to do little tick marks to represent all the different numbers that I need. So here's going to be 1, x equals 2, 3, 4, 5, and 6, and y equal to 1, 2, 3, 4, and negative 1, negative 2, negative 3, negative 4. And what I want to do first is start at the vertex. So the vertex was the very, very middle point. And that is going to be at the point 4, negative 2. So I go over 4, 1, 2, 3, 4, and I go down negative 2, 1, 2. So I'm going to make a point right here. And this point is what we call the vertex. And what I can also do, I can also draw a line along here at x equals negative 4. That line has a specific name. It's what we just found. It was the very first thing we found in this kind of problem. It is the axis of symmetry. Okay, we're getting somewhere. We're starting to see a little graph coming out. We've got an axis of symmetry. So that means that anything that I draw on the left-hand side of this line is going to be the mirror image, a reflection of whatever I draw on the right-hand side. Let's see if that holds true. So now I can look at my very first point, x equals 6. When x equals 6, y is equal to 2. So I come over 6 tick marks. 1, 2, 3, 4, 5, 6, and I go up 2. 1, 2. So I'm going to put a point right here at 6, x equals 6, y equals 2. Now I need x equals 5, y equals negative 1. So I count over 5 and I go down 1. If I'm at x equals 3, y is equal to negative 1. So I come over 3 and go down 1. And then finally, x equals 2, y equals 2. So I go over 2, go up 2, and I draw a point right there. And then I can draw a kind of curve shape that connects all of these. And this is the shape of my parabola. And I've done that by first finding this axis of symmetry, by finding the x equal to 4, and then I plug this axis of symmetry in to find the vertex point, and then I just pick different values for x and solve for their corresponding values of y. So I can actually make these points and draw out this shape for this graph. Okay, one last thing to go over. Let me redraw the same exact graph that we just had. So we have a y-axis and we have an x-axis. And I have my tick marks, 1, 2, 3, 4, 5, 6. I have y going up 2 and down 2. And I draw my little points. I drew my dotted line around the axis of symmetry, which was at x equals to 4. So there's my dotted line. My central point, my vertex, was at the point 4, negative 2. So I'm going to draw that in. At 5, I'm at negative 1. At 6, I'm at positive 2. And we solved all these values. This is everything we've already done for this problem. Okay, so now how do I actually draw this shape? Well, it depends on what kind of equation you're given. Let's say instead of being given y equals x squared minus 8x plus 14, I was told that y is greater than x squared minus 8x plus 14. That should be a 14. Make that a little bit more clear. So instead of having an equal sign, I'm given a greater than sign. Well, in this case, my parabola that I draw isn't going to be a solid line. It's going to be dotted. Because this is greater than, and not necessarily equal to, I have to draw a dotted line for my shape. And because y is greater than, then y is only going to be specific values. And I can shade those values in. So I can shade them in. And since y is greater than, I want to shade in areas that are greater than this. So this would be what my graph looks like. Nice and shaded in, shading in above the parabola because y is greater than, and it's dotted lines because y is not equal to. So let's see some more examples like that with this kind of inequality kind of equivalence. Instead of having an equal sign, we have an inequality. Okay, here's my parabola. Still looks like the same shape. And instead of doing y is greater than x squared minus 8x plus 14, let's do y is less than x squared minus 8x plus 14. Now in this case, I still have the dotted line. The dotted line because this is an inequality. There's no equal sign going on here. But now, instead of being greater than, I'm now less than. So I want to shade in the areas that are underneath this graph. The areas that are down here. Okay? So that's how you kind of figure out what the graph should look like. Let's do one more example. One last little guy. So you have the same thing, and instead of doing y is greater than, let's do y is greater than or equal to x squared minus 8x plus 14. Still have the same parabola, still have the same shape, but now we're greater than or equal to. Well, I can do shading. I know that y is greater than, so I can shade in any area that's above. But now I'm greater than or equal to, so I can actually be along this line. So instead of doing a dotted line, if you have a greater than or equal to or a less than or equal to, you have a solid shape, a solid line for your parabola. And this general form, this general structure will work for solving all the rest of the problems on your worksheet.